What's going on everyone, and welcome to part 16 of tutorial series on AWS Audio Analysis. Till part 15 of this tutorial series, I have covered a simple sentiment analysis for a given audio. And now starting with part 16, I am extending the tutorial series further with the real world use case of call center audio analysis, or we can also say customer agent conversation sentiment analysis. So ideally we will implement sentiment analysis on separated transcribed audio of agent and customer respectively. So here I have come up with a high level architecture diagram, but as you can see on my screen there are two architecture diagram. The architecture diagram on the right is our old architecture diagram that we have followed till part 15 of this tutorial series. And the architecture diagram on the left, that is something we are going to follow further in the upcoming tutorial. So that is our new architecture diagram. So what I will do is I will just simply close the old architecture diagram and we will shift to our new architecture diagram. But before I start, I encourage you to watch previous tutorials of this series to better understand the further tutorials. Since this is the extension of this series for a new use case, I will be reusing the resources that we have created at that point of time, that is in the earlier or the previous tutorials. So if you want to refer it, then you can find the link in the video description for those tutorials. So now coming to our new architecture diagram. So you can see there are two colors, that is yellow and red. So if we look at here, so yellow says require modification and red says resources to be created. So the resources marked in yellow are already created and it requires some sort of modification as we are moving further with the different use case, right? So we will modify those already created resources to fit our new use case. And the resources that are marked in red, that is ideally two resources, that is AWS Lambda and Amazon S3 bucket, right? So that are supposed to be created. So ideally we have to create two new resources here and rest of the architecture remains same as our old architecture diagram, correct? So let's go to each of the resources one by one. So we will start from here. So from here our file gets dropped into S3 bucket and it gets saved into this folder, that is audio file, and finally it triggers this lambda function that is marked in yellow. So we have to modify this lambda function to handle speaker diarization or speaker identification, for example agent and customer. So as I mentioned earlier, we are going to perform sentiment analysis on the individual transcript of agent and customer respectively. So that is where we have to modify this lambda function to fit in our new use case. So moving along, then it triggers Amazon transcribe. I mean it creates this job for transcription, and finally the outcome is saved in this S3 bucket. So now the output that transcribe will provide for each speaker, each separated speaker will be in chunks along with the timestamp for the respective speaker. So is that in our case it's customer and agent. So earlier this S3 bucket triggers this lambda function, that is sentiment analysis, but now two new resources have come into picture. It's because as I said, the outcome of the transcribe will be in chunks along with the timestamp. So it's not going to be a separate transcription of customer and agent individually. We are going to create this lambda function, that is ideally the helper lambda function, to handle that scenario, right? So the outcome of the transcribe will be dropped in this S3 bucket and it will trigger this lambda function. Now what this lambda function will do is it will work as a utility function to put together a text for respective speaker and then it will store the output in this S3 bucket in the JSON format. Then it's going to trigger our sentiment analysis lambda function that is ideally responsible for performing sentiment analysis. So we are going to modify that lambda function for sentiment analysis to handle analysis for an individual speaker, right? So apart from that, also we are going to add few more attributes to the outcome while saving the final JSON in this S3 bucket, but we will come to that part later. Now moving along to AWS Glue. So in terms of AWS Glue, we have to update the table schema because since I mentioned to add few more attributes to the outcome, hence our table schema is going to change. So as a result, we also have to update our Amazon Athena query with respect to the table schema updation for data retrieval. Correct. So that's Glue and that's Amazon Athena requires modification. Now finally, in terms of Amazon QuickSight, we might end up creating visualization or maybe modify the existing one. So maybe you can go ahead and comment below on how you want to take this up. So if we are going to create a new one, then it should be in red. It could be in yellow if we go ahead and modify the existing visualization. So that is something I am leaving up to you. So that's the overview of our architecture diagram that we are going to follow in the upcoming tutorials. Correct. So that's it for now. So in the next tutorial, we will start with the modification of this lambda function that is over here for speaker identification. Okay. So as usual, if you want me to do tutorial on any use case or service, then please leave them below and I will try my best to come up with the tutorial as soon as possible. And if you have any queries or comments, then please leave them below and don't forget to like and subscribe to my channel, and see you next time.